Welcome back, guys, for another quick video. And what we've got in the shack today, we're going to take a look at, is this interesting VFO or PTO, which was used in a lot of Collins equipment, and particularly the R390. And the Collins equipment in general has quite a good reputation for being sort of really top quality and well engineered. And I managed to find a couple of these VFOs or PTOs on eBay, and I thought I would grab a couple, probably for future projects. This thing's really, well, I guess almost over-engineered in terms of VFOs, variable frequency oscillators, and it's quite interesting to have a look at it. If you compare it to the previous video I did on VFOs and everything, and you look at that one that I demonstrated there, which was a very sort of typical VFO design, this thing takes things to a different level. This VFO is actually made by Dubrow. I don't know if you can see it there, and I guess that this may have been sort of subcontracted by Collins for some of their equipment, but it's pretty identical to the other VFOs in other equipment. Now this one, I believe, and a lot of these ones which you find on the internet actually come out of the R390 receiver, which was a sort of general purpose high-end receiver. Anyway, let's just have a quick look at it in a bit more detail. So we've got this sort of case here, which contains basically the tuned circuit. Now these Collins VFOs are a bit different from normal ones because they're often referred to as PTOs, Permiability Tuned Oscillators. When we open this up, you'll see what I mean. Most conventional VFOs use a variable capacitor to vary the frequency of the tuned circuit, but Collins, when they first started doing this, they decided to use a variable inductor by changing the inductance with a slug, hence the permeability tuned. We've got a single pentode there. That's a 5743 or 5749, sorry, pentode, which is doing all the work. And then there's a little screen case there, which is a tuned circuit in the anode of this tube. So looking at it from this side, we've got a shaft there, which that basically would go to a dial or whatever. So let's have a quick look inside one of these, and I've already taken the screws out just to make things a bit easier. So I'll slowly remove this. We've got some wires coming out of this case here. We'll just pull those out, and if you look here, now I've taken this thing, actually had a bit of insulation or wadding around it, some insulation foam, and the reason for this is this brown thing here is actually a thermal heater, for want of a better word. And you've got here a thermal switch. So what this shroud here is, basically it's an oven to keep the temperature constant. And you know, as I said, they didn't really cut any corners with this oscillator. So if we take this off, we can see there's another screened case underneath. Just give that a bit of a wiggle. That's it. Try and move it to one side. So you can see there's another screen case. I mean, this thing is really like playing around with one of those Russian dolls. You know, you take one case off and you've got another and then another. I was actually surprised that there was another one underneath here, and this actually is or would have been sealed. So it's going to take a little bit of a... see if we can open this up. Might need to... oh, there we go. Voila. So let's take a closer look at this. So that's the inside of it, and you've got, well, that thing up there is is some silicone gel just to try and keep everything dry. You've got rubber seals here and here, and if I twiddle the knob, I don't know if you can see that. You can see the slug moving into the coil. There you go, to vary the frequency. You've got sort of a funny thing there, which is some sort of cam, I think they describe it as, sort of aid with the movement. So moving this thing round, got a capacitor there, and probably some sort of trimming capacitor there, or probably compensation capacitor for the any changes in temperature, whatever. So that's the main tuning components, I would say. So as you can see, they really went to town with this in terms of engineering it to a very fine or very high standard. The only other thing that's worth taking a look at is inside this part here. I'll have to undo some screws and we'll have a look inside that, because there's not much in there. It's where the valve goes in, but we'll have a look inside there quickly. So taking a look inside here where we've taken the cover off, we've basically got some wires coming in, and this is obviously for the HT supply for the pentode, and also for the heaters, for the heater supply. What's interesting though, the actual valve base is down there. It's difficult to see. It's right down the bottom there. But what's interesting is the way they've done these decoupling capacitors. So they've got all these, again, I'm not sure if you can see that, but this little block here is actually full of ceramic decoupling capacitors, and they're all sort of on in a resin block, all sort of glued up together. And then you've got they've all got a sort of common earth all joined together. So this is really sort of you know, very well engineered, very well put together to try and make sure that the VFO is as stable as possible. Anyway, what I'm going to do is put it all back together, and we'll try and fire it up just to show you that it does actually work. Right, we've connected everything up here with this Collins PTO, and I don't know if you can see it there. Just move it slightly, dim the lights. Yeah, you can just about see it. The filament on that 5749's glowing nicely. So what we're going to do is put some HT on this and we'll have a look at it on the scope to see if this thing produces any output. Right, just going to switch it all on. Right, let's switch on the HT. Reach over. So there we go, that's the output of the PTO. Not too bad. Now apparently this unit is supposed to cover from about 2.4 to about 3.4, but you can actually adjust it, and I've adjusted it so that it will actually go almost up to cover the whole of the 80 meter band without us having to modify it. Just move the adjuster, or the you can just see the frequency changing there. Let's just rig it up to the frequency meter. So there we go, that's the frequency I've got on the moment, 3.522. I haven't got the oven on, not to bring any cakes in it. I mean the oven around the VFO, and yeah, this looks pretty stable, but I'm not going to leave it on for hours and hours. But I think this thing should be pretty good. According to the blurb that I found on the internet with these, they're almost as stable as crystal oscillators, so you can see a lot of potential. But this thing will actually go all the way up to about 3.78, so that covers most of the 80 meter band. I haven't had to add extra capacitors or anything, which is quite good. Anyway, so there we go guys, that's a Collins PTO, and if you're thinking of making a transmitter with a VFO, which is going to be reasonably useful, then I recommend trying to find one of these. I think there are a few out there on places like eBay, and I'm sure especially in the States where I got this one from, there'll be quite a few of these knocking around radio rallies and all that type of thing. So thanks for watching, and until next time, cheers for now.